Yeah, Dhanlakshmi, can you please confirm if my audio is correct today? I tried some changes. Can you please confirm? Anyway, hi. Hi, Ritesh.
Yeah, hi Vasant. Yeah,
Yeah. So, Dhanlakshmi, can you confirm my audio quality? Yes, it's good today. Awesome. Yeah, really awesome. So, yeah, whoever is there, actually, it's going to be very interesting because today Ritesh will also be talking about AutoML. I asked him to talk about it actually because everyone is thinking AutoML is like taking over jobs, everything those are all myth and yeah, there are some good things about AutoML also. So everything Ritesh will be talking about that actually. So yeah, it will be very interesting after that. We'll be covering obviously I'll be covering pre-processing today. Pre-processing will be completed. Okay, as usual, why, what, how, every questions will be answered, okay, for each step. So today it will be feature scaling and train test split. So once it is done, we'll be also saying various ways to do feature selection. And we need to have a Google account, right? For what why do you need Google account? For AutoML. AutoML is automated ML. That's all. Ritesh, can you put a few words on AutoML? Just an intro.
yeah. So see, you
Yeah,
all
tell me
have
maybe.
seen about like yes, yes, yeah, sure. Let me open my camera. Wait a second. Yeah, great. So you all have seen about like you generally build your machine learning model like you use random forest classifier or logistic regression or any like there are a lot of models which are present in sklearn. So but nowadays what is happening like we are using two terms like we are having automatic and we are having machine learning. So what we have done, we have combined that term and make our machine learning process, or uh, you can say our machine learning process automatic. Like just we are sending the data and we are getting a comparison between many models. You can say 10 to 20 models. We are getting a lot of comparison between accuracy, F1 score, or kappa score, and these all like different metrics depending upon the task. So this is known as AutoML. Like in AutoML, let me share you. Let me give you some introduction towards AutoML. Let me share my screen. Wait a second. Let me tell you now. Okay, entire screen. Okay, great. I guess Vasan, bring my screen onto the stage. Okay, yeah. Let me show you. See, in AutoML. So what is AutoML? So one of the famous tool in AutoML is PyCaret. If you have if you are following Moisely, so he is the founder of PyCaret tool. So what is PyCaret? Inside PyCaret, you just need to send your data. You just need to send your pre-processed data. And as the output, you are getting some kind of a long table. You are getting a long table of comparison between different, you can say, let me tell you how you can go through with this. You are getting some kind of a long table comparison between a lot of models like XGBoost, CatBoost, Random Forest, just name it. You will get each and every model there. And inside that you will get a comparison between different metrics. Let's say we are having regression problem, so we are having RMSE, MAE, MAPE, and different scores, Jacquard score, a lot. You will get just a comparison between different models, like how different models are behaving. So here you can see this is the best way to get started with, you can say, um, PyCaret. So let me show you one thing. So getting data. Okay, so let me go through this only. Okay, so this is how it look like. Here you are having different data. The data, this is the data repository. You can take any data from here. Then after taking the data, or you can put your own data inside PyCaret. After that, compare model. Now this task is involving the comparison of different models. Like this. At the end, what you are getting, let me show you the output. Sample output, this is the output you are getting. You can see we have taken a particular model. We have specified a metric like on what basis you are going to short your model, either on the basis of AUC score, ROC score, or let's say if it is a classification problem, you are going to short it in the basis of F1 score or precision or recall, any. So here we have taken a AUC score. So it is default is accuracy. By default, it is accuracy. But if you are mentioned to short this in the for using AUC, you can use that. Now it will compare different models. You can say extra T regressor, cat boost regressor, gradient boosting regressor, a lot. You can see here different models on different metrics which are present in regression problem. And at the end, it will give you a best model. Like extra T regressor is working best on these four metrics, and you can say cat boost is working on this. You can say top three models. It will give you the best one. So this is known as a simple what it is known as a AutoML. So we are doing nothing, just taking our pre-processed data set, feeding it into a tool like this, like known as PyCaret. Just feed this, you will get this table. Now from get the best model, like XRT regressor is working best, so it is ranked at the top onto the 0th position. Now and the tally goes on like 0, 1, 2, 3 and so on. You can choose any model. And this will give us a insight like this model is working best. Like XRT regressor is working best. If we are doing these all things manually, it will take a lot of time to perform comparison between such long list of models and to get a score. These all kind of a metrics like mean average, mean, you can say mean squared error, mean absolute error, root mean squared error. How many metrics you can check using a skiller? It will take you a lot of time. So to do these all process, you can say fast. We are having PyCaret. In a similar way, there are a lot of tools which are present in the under the hood of under the hood of AutoML. So some tools are H2O AI. Just search for H2O AI, you will get. This is one of the world biggest AutoML cloud platform. You can say this is one of the world biggest AutoML tool. It is used for a lot of purpose. You can say it is. You can say a professional version of PyCaret. It has a lot of things like if you can see their solutions, what all they have built, what all platforms they are having currently, what all you can say open source tools they are having sparkling water, they are having H2O AutoML. So our interest is H2O AutoML. So let's go to learn more. So if you click on to the learn more, you will get a huge lot of guide here. Now in this, they are not only having a command line version, but they are also having a, you can say, a web GUI, web platform they are also having. Let me show you here. You can see here. This is their web platform. So this is one of the advanced tool. You can even use this tool. I guess they are also supporting Hadoop and Spark clusters and Kubernetes cluster nowadays. So these all are one of the advanced tools. But at the end, these tools are not at all used by the machine learning engineer. Let me tell you why. So let me show you one more tool. One more tool. I guess it is Teapot.
Ritesh,
Yes, yeah.
there are some questions here.
Yeah. I will take a look. I will take a look. So let me show you. Let me show these first. Then I will take a look onto them.
Okay.
Okay. So there are having VRML. So if you search for Teapot ML, you will get this is also one of the famous AutoML libraries which are available. So let me open this. So you can even use this. So one of the best way to get started with any library, just go to their documentation. For PyCaret, you can see it is very easy to follow up with their documentation. You can have a lot of things here, like stacking, blending, assembling of the model, even a lot of things. At the end, you can even deploy the model. So this is all you can say are the available AutoML tool. And one of the best tools are PyCaret and H2O. And the second thing is we are having tuners like Keras tuners. This is also, you can say, kind of a automation we are having, but this is used by many people because like in the search of hyperparameters, let's say you want to search a parameters, you can use these all this tool, Keras tuner, like number of layers, number of learning rate, what is a good learning rate, what is it good weights, good bias, you can take a look onto this. In a similar way, we are having, let me show you first so that you can get to know about what all things are available in the market, so you can explore it according to you. Hyperopt. So Hyperopt is one of the library. Let me show you their website first. Hyperopt. Okay. Okay. Hyperopt sklearn. So this is their library, I guess. Okay. Hi. So this is their library, Hyperopt. So Hyperopt is also used for, you can say, performing hyperparameter tuning, some kind of a automation task they are having. So these all are the libraries which are available. Now, what is the problem? At the end of a day, if you are a machine learning engineer or you are working in any field, whether computer vision or NLP, you are not going to use these all libraries, except that hyperparameter tuning frameworks like grid search CV and random search or Keras. So why you are not going to use these all libraries? Because you can't have too much control over them. You are sending the data, you are sending your pre-processed data, they will giving you the comparison between the different metrics. But let's say you only want to send only particular features, you only want to send the particular columns or particular features, or you want to do some kind of a you can say pre-processing at the time of training, such kind of a operation. So it is very difficult for you to use this kind of a tool. So for that, you need to work manually. You need to have some kind of a control. You need to work using that sklearn library. You do not go with this PyCaret. Most of the people do not go with this PyCaret. But how people are using, why these libraries are used? They are used. So how they are used? Let's say you are having a data, unknown data. Now you want to study about the data. So what you can do? You can just feed them into the model. You are going to just feed them into the, you can say, PyCaret pipeline. So once you have feeded them into the PyCaret, it will give you the comparison. Now you can take a look which model is working best. Now delete that PyCaret and use the sklearn to work on that model, so that you can even perform hyperparameter tuning by yourself. Because PyCaret and H2O, these are libraries are not too much good in hyperparameter tuning. If you can say the best libraries are grid search CV and randomized search. So this is all, like, the main reason do not to use these all libraries is that you don't have any kind of a control over data. You want to select particular columns, you want to scale them, you want to do another thing. Let's say you even want to do some kind of a hyperparameter tuning. Now how you can do that? They will just give you comparison of a list of comparison. Now for that, the best way to use this library is to just get some kind of insight about the data. After that, you can switch to that your sklearn work, what you are currently doing. Okay, so any query, any doubt, you can drop onto the chat. Let me take a look.
There are a lot.
Okay, yeah, let me take a look.
I'll
Lot
just
of
ping one more.
yeah, awesome. So a lot of also is PyCaret part of,
You can
it
you
is
can
a
stop your
part of
screen
a
share.
PyCaret.
You can stop your screen share.
Sorry for this. Okay, cool. Yes, PyCaret is a part of Automl. Yeah, it is one of the best library which is available currently. Like after the H2O, H2O is the paid one. They have H2O AutoML, which is the free library, but most of the parts, most of the part of it is paid. H2O, so PyCaret is the one of the best one. If there is any drawback on PyCaret, yeah, see, I have told you about the drawback now. So you can't have any kind of a such kind of a good control over the data, over your model training. Like in the model training, you need to do many steps, like parameter tuning. You need to take a look on you. If let's say if you want a particular metric, you want an RMSE, you don't want such a long list of a metrics. So if you are doing a model training by yourself using sklearn, then it would be beneficial for you. But you can use PyCaret at the initial. Let's say you don't know about the data set, you have pre-processed it. Now you want to take a look which model is working best. So you just pass it onto the PyCaret, get that model, and after that use that model to work to proceed your work further. Okay, I hope it is clear.
Okay, coming to this doubt, are we going to play around with PyCaret and H2O? No. That's why
Yeah,
brought this. I
it is
brought this
very large.
topic. I brought this topic today because, see, the only thing is you can use AutoML just as he said. You can't pre-process your data. No, it's not possible by using AutoML. And then the second is we can't do hyperparameter tuning and all. We can't play with the model. We can just get which model is better. So the point I'm trying to say is AutoML is not going to get our jobs. You are accepting or not, Ritesh? Is it going to replace
Yeah,
it?
see, yeah, no. AutoML is for those people who has a very less knowledge on machine learning. I guess they are using AutoML. So the actual machine learning engineer don't prefer AutoML tool, but it is, you can say, to get a initial comparison. It is, at the end it is good,
Yeah.
but
So
not like these all operations to perform heavy operations.
correct. See, there are a lot of even EDA libraries are available. Most famous libraries Miro is available, or else you can go for Pandas profiling. These two
Sweetwiz,
are
Sweetwiz,
Sweetwiz is available,
Sweetwiz.
but all are
Detail
just
is
to
also
get
there.
graph. All are just to get graph. You can't do pre-process of your data set. So that's why I brought it today, because we are completing pre-processing today. So why I took 5 days for this is nothing can do this work for you. You should do by yourself. You need to analyze yourself, and then you need to analyze the data, and then you need to play with it can't be done by any AutoML or auto EDA libraries. Okay, that is the specific reason I brought about AutoML EDA today. So you can ask, Vasan, then why you built Optimus? Because I was showing you all day. It was just to aid me. So, it is kind of a toolbox for me. I know that I can do random sample imputation at there. What I'll do, I'll just call that function at press. That's all. Simple, right? I'm not using it as a automatic one. I'm just supervising it. I'm just making my task to do by someone. That's all. But I'm doing it. I'm supervising it. So that's how you need to work. Okay. So there is a reason I brought. Okay, that is done. Lots of optimal tools. Yes, yes.
Okay, so which tool, which type? Yeah, see, in deep learning there are very less. There are very less tool, but now these PyCaret and H2O are moving towards deep learning also. In NLP there are very less tools which are available currently. Uh, but in machine learning
But
there are a
why
lot.
why NLP or automatic? You're having auto NLP. Why
Yes,
auto
yes,
NLP?
yes. Auto NLP. Yeah. I forgot. Like,
Yeah,
yeah, we are having auto NLP by Hugging Face. Like
yeah.
it is. You can say, but it is far best than these all kind of a tool. Like you just feed your model, feed your data inside that textual data, and it will give you the output. It will give you the saved model.
Simple.
Like many Kaggle competitions, many Kaggle competitions uh, can be, are done. Like top 100 people are using like AutoML, but it is a paid service, so it is not applicable for everyone. But it is one of the best tool which Hugging Face has built now, like AutoML. Auto NLP, sorry, Auto NLP.
Can grid search
Yeah.
and randomized search consider as AutoML? No. I'll explain about these things because we need to talk about hyperparameter tuning in your model tuning section. At the time, I'll talk about this in a detail.
Yes. Yeah, it is definitely like black box. You can say like,
You don't know what is going on there. You don't have a
yeah, it
control.
is definitely.
The main thing
Yeah,
is you don't have a control. You don't even have a single control of what is happening there. You should just fold your hands and then wait. Okay, you do whatever you do. That's all. That's how
yeah, true.
that AutoML whatever is in existence now is like that. So that's why I try to make Optimus. Yeah, it is not a successful one still. I have not completed it yet, but if I complete it to my vision, whatever problem I'm now putting forward towards AutoML, everything will be resolved in that AutoML. I'm just making a flow of it, but if it is done, it will be create clearly the best AutoML package. Yeah, that's how I'm trying to create it. Great explanation. Yeah, always Ritesh is a best in that. He can do explanation in a very good manner.
Yeah, we are having ML ops like then
Yeah, at that time,
ultimately onto that like
at that time, you will all know, like, what is he like? Where was he, man? Like, I think you should have handed over the bootcamp to him. That's how you will all feel when he is going to take about deployment. I'm very sure on that. So
oh
yeah, that's what I start wanted to start with today. I thought of putting it at the end, but, like, at that end, I don't know what will be, like, how many people will be seeing this. So I just wanted to put it at the before itself. Now let's go on with today's topic. Okay. So in today's topic, we are going to talk about feature scaling and feature transformation also, like, scaling and transformation both are coming under transformation. But yeah, I'll say about that. We'll also be seeing about train test split, and I'll give you some introduction of, um, like, feature selection and feature extraction. I'll do feature selection tomorrow, okay? But feature extraction, no. I'm just going to say how we can do it, and I'll show you an example. But we are not going to use feature extraction in this data set, okay? So yeah, let's go on with the session now. I'll just share my screen, okay? I'm just firing up my VS Code. Yeah, just put on your doubts. Until then, I'll just run this and then make a CSV out of this, and we'll create a new, uh, like, notebook actually. Again, I'll not be doing for the entire data frame. Okay, it's not possible because not we have not handled the whole data frame. Like, we have just handled some part of it, so we can't run for the whole data frame. But yeah, we'll be doing it for the some part of the data frame. Okay, some columns. I'll just show you as an example. Until then, yeah, you just should put your doubts here, and we are also having Ritesh here. He'll also answer your question. Okay. Where is it? It is running here. Fine. Yeah, it is taking some time. Okay, now it's fine. I'll just put. I think you all know this function df dot to underscore csv. Okay. Here itself, I'll put it as processed dot csv. Okay. So if you need this specific data set itself, just put it in the chat. I'll just put it in, like, we transfer, and I'll put the link also in the chat. Could you please upload the day 4, day 3, and day 4 codes too? Or could you please share the link where I can download the whole code and run along? Lost some in yesterday's session. Today it will be uploaded the whole code because I was waiting to complete the pre-processing. Okay, I was completely waiting for that only, and today, as it is completed, today night the whole code will be uploaded. To follow along with me now, okay, I'm just putting V transfer. Okay, just a minute. Login. I'm just sending you the dataset which we are using now. Like, yeah, it is the same dataset, but we have processed some things, right? So you might need that. Okay. So where is it? We transfer. Here it is. Yeah. I think if I do like this, also it will work. But I don't know. Okay. I'll just click it itself. Processed. No email. Just a minute. Or just the process CSV file. Yeah, yeah. I'll give the process CSV file. Just a minute. Just a minute. It is uploading. Okay. Yeah, I've pasted the link in the chat. Okay. Just click it and then get the data set. So once you get it, just put it in the chat. Okay. Once you get the data set, just put it in the chat and then I'll start the session. Are you able to download? It is asking me to sign up. Yeah, yeah, you need to sign up. Okay, got the file. Thank you. Awesome. Awesome. Let me share my screen again. Okay, now it's fine. Create a new notebook. Okay, this is just for your following, like, feature transformation. Yeah, if possible, I'll also do feature selection. Okay, now why do we need feature transformation? Let me open my whiteboard as usual. Actually, today there won't be a lot of writing, actually, I guess. So, yeah, feature transformation. Okay, just a minute. Yeah, I think now it's fine. So, what is feature transformation first? Okay, what, why, how? The usual questions. Okay, what? Actually, here when also is important. When. So, what this feature transformation is that transforming features to our need in a specific range slash pattern. Okay, so that is feature transforming features according to our needs. So simple also you can say transforming features according to our needs. That's all. Okay, why it is needed? Better performance of models. Simple, that is the reason. See, for example, you are having linear regression. Okay, previously it was 10, 20, 30, 1, 2, 3, 4, 5, and 6, 2 and 4, and maybe for this 5. Okay, so as this is in different range, what will happen is it will go like this. Okay, it will miss this. or else it will go like this and it will miss this. Okay, so if I'm putting it in a specific range between 0 to 1, again it will be like spread out, but the direct, the error error rate will be very low. Okay, the difference between the predicted value and the actual value will be very less. So that will be one advantage. Okay, so we are having everything in the same range, so the mathematical calculation is also easy. Okay, so this answers the question why, how. So we are having different method: normalization, standardization. Actually, there is one thing called robust scalar. Okay, that also is needed. And then the fourth one is Gaussian transformation. Under that, there are a lot of things like for example, log. Is there, so log, exponential, square. Okay, so along with that there is reciprocal, and then one of the best transformation, which is box Cox. Okay, these are all the transformation methods which is available in the market for now. Okay, now I'll explain what are those in detail. Okay, so what will normalization do is, normalization is all about just like putting the values between 0 to 1. It will just make it 0 to 1. The formula is, I'll show you. Just go to the sklearn documentation. Just go to the sklearn documentation. Sklearn normalizer, not normalizer, actually it is min max scalar. Okay, for normalization you need to use min max scalar. So the formula is, see here, x minus x min by x max minus x min. That's all. Are we calling feature scaling as feature transformation? See, scaling, we are terming it as transformation because obviously you are making a transformation there, right? Yeah, you are scaling it, but there is a transformation, there is a shift in the data where it is moving from one range to another range. It has been transformed. So we can add it under feature transformation. That's all. We are not calling it as, we are like putting it under feature transformation. But anyway, yeah, good question to ask. So normalization formula is x minus x min by x max minus x min. So where we will use normalization? Usually we use it with deep learning algorithms. Okay, in deep learning algorithms we use normalization a lot. Now coming to standardization. It will put the values between minus 3 to 3. Okay, where mean mu equal to 0 and the standard deviation will be 1. Okay, it will try to make the data in this range. So what is the formula is the z-score formula, x minus mu by sigma. Okay, by doing this formula it will make to fall under this range. Usually we use standardization with ml algos. Okay, in ml algos we used to use standardization a lot. Now robust scalar. This is used, but yeah, it's not very important. For that reference, you can just go to sklearn again. Okay, just put robust scalar. Okay, see here it is. Okay, so it will be using IQR. We know what is IQR by now, so it will be using IQR method. Okay, so based on that, it will make a transformation. See, the scalar removes the medians and scale data according to the IQR. That's all. It will make sure that everything falls under first quartile and third quantile. Okay, that's what robust scalar does. So it is robust to outliers, which means if you do robust scaling, then you need not do outlier handling. Simple. Okay, so robust scaling uses IQR. Data falls between first and third quantile. Okay, robust to outliers, which is commonly used in ML again. Okay, so yeah, now coming to Gaussian transformation. So the first one would be log, second one would be exponential, third one reciprocal, fourth one uh, square wave, sorry, square. Okay, finally box Cox. Why I'm drawing small line is because this is not a very tough task. Log means log of in simple. That's all. I'll be adding one along with that because um, like log of zero is one, and log doesn't perform very well with zeros. No, actually log one doesn't perform very well. So that's why we use plus one. Okay. So there is another thing also called log 1p. You can also use this. Okay. So, and also when not to use either of them. Could you help with the use cases where we use min-max scalar and standard scalar? See, what about use cases? See, like I generally say, ML and DL. That's all. Specifically to say use cases, there is nothing like that. If you want to scale, just scale it. That's all. Okay. It is not going to reduce your performance. It is either going to make no effect on your performance, or else it's going to increase your performance. So it's upon your wish. Do any of those. Okay. But be sure that if you are scaling, okay, use the correct scalar. That's all. Like instead of just making maybe uh, exponential, don't use log. Okay, or log exponential, don't do in this way, it will give bad results. So be sure you are collecting the, you're choosing the correct one for the correct data. For example, for skewed data, as I said, log. Okay, you can just go away with your closed eyes and then say, I'm going with um, log. That's all, simple. Okay, like that you can do. And when not to use either of them. So as I said, it's choice. If you're doing Gaussian transformation, choose based on the features. Okay, so make a QQ plot. Okay, and then try to find the line and how much the data fall in that line. And if it is falling, yeah, it's well and good. That's all. Nothing more than that. We can't say at this specific time you should not use, or at that specific time you should not use. We can't pinpoint it in that way. Okay. So did you get the point? Just confirm, guys. Did you get the point or not about when to use and when not to use. Because if you confirm only, I'll be able to move into the next topic. Okay, then I'll take it as a yes. Okay, so for log, as I said, just make a log. For exponential, okay. So usually log we use it under skew dataset. Okay, so be sure that when you are having a skew dataset, you just choose log. Okay, so for exponential, we used to do power 0.2. Okay, stars are 0.2 is like constant we use, but if you want, just change it to 0.5, 0.6, whatever you want, just change it. Okay, it's upon you. I've confirmed as okay. Are you getting my messages now? Yeah, I'm getting your messages now only. I didn't get it previously. So you can use any of the power. It is just to raise to the power. That's all. Okay. So exponential is about that only, nothing more than that. Okay. Reciprocal means making an invert of the data, one by data. Okay. So just a minute. Sorry. Um, just went for a minute. Okay. So yeah, I hope then you got it. Okay. So reciprocal is one by data. Okay, that's all. Whatever data you have, just put one by data. And then for square, star star 0.5. Okay, square root. Square root is called a square. So yeah, if you want to make a square, it's upon you. Just change it to zero power two instead of 0.5. Okay, so yeah, that's it about Gaussian transformation. Okay, as I said today, it's not going to be a lot to write. I'm just going to see do the hands-on now. Okay, so let's do it. Import. Why is it capital? Import. If I find time, I'll also go for like feature selection. We need this sci-fi dot stats as stats. Looking good. Yeah, looking good. So next we need to read the dataset. pd dot read underscore csv process dot csv. Okay. Okay, it's processed. Okay, somehow it is. Okay, so be sure. I'm just going to make df.d types first. We are just going to make a data frame of 5 columns, okay? Not more than that. We are just going to play with only 5 columns. So if needed, we can take some more columns at the later part. So you can think like, why I'm doing like this. So it is just to like, we are just practicing it, and we didn't do missing values handling for all the columns. Even I need to check if there is any missing values in this column. If it is there, we can't do anything. We need to handle it first. Okay. So yeah, let me check it. In Gus Steve. Okay, I didn't put. Okay, what happened here? Okay, let me try like this. Now it should work. Yes, BF1. Now it's fine. Yes. So BF1 dot is null. Okay, in everything there is a missing value. I'm just going to do BF1 dot drop NA in place equal to true. We are not going to handle it. Okay, we are just dropping the columns. Now BF1. So yeah, now it's fine. Okay, so I'm also going to make a df2 equal to df1. That's all. Okay, we'll need it for Gaussian transformation and all. We'll make some copies possibly. Okay, so I think along with that, df3 equal to df1, df4 equal to df1. So you might think like, why I'm doing like this. df1 is for min-max scalar, which is normalization. df2 is for standard scalar. df3 is for robust scalar. And df4 is for Gaussian transformation. Okay. So yeah, now we are looking good. So let's go for normalization. Okay. Okay. Actually, we can do this also, but we don't need that. We didn't expect this, right? But actually, this is the thing we are going to do, but in a different way. Let's learn no pre-processing import min-max scalar. Scalar equal to min-max scalar. Scalar dot fit of df. Return dot scalar. Scalar. Fine. df1 actually for us. Okay. Okay, we are passing it right. So this also should be fine. So this would be the code. Okay. So let us try it once. Normalization of df1. Okay. It should have changed actually. Actually, this is what. Okay, let me do it like this. df1 equal to normalization of df1. Now, yeah, it's fine. See here, it has been normalized, right? So this is how we need to do normalization. How did you handle key error? Which error? This one. Key error means there is no column like that. You would have missed a bracket, or else you would have missed a column name. Yeah. So it happens. Just check it. Okay. So one thing I think you will all know that everyone get coding mistakes. Okay, even so, I also get a lot of mistakes when I'm doing. Okay, now for the next step, which is standardization. Standard. Here it is. What more I need? Simple. So we are importing the standard scalar, we are making an instance of it, we are fitting it and transforming it. So you can also do fit underscore transform, it's upon your wish. Okay, let's do standardization of, I don't want df1 this time, we need df2. Okay, um, df2 equal to standardization of df2, we'll now print it. So here you can see, right, minus 1 and all is there. So as I said, it will be minus 3 to plus 3. Here it will be 0 to 1. If it is more than 1, it is termed as outlier. Okay. Less than 0 also outlier. So it won't be actually there. That's what the thing is. So df2 is done. Next for the robust scaling. Def robust scalar. Awesome. This is what we needed actually. So guys, do you need to know how I'm doing this autocomplete? Do you need a video on that? I can also make a video on that actually. Hi Darun96. Hello. Hello, hello. Welcome to the live. Okay. First time I think I'm seeing here. I'm seeing you here. Anyway, hi. And guys, if you want to know, how this autocomplete is working for me alone, yeah, you can just say a video, say it in the comment section. Just make a video, and then I'll make a video for sure. It is based on GitHub Copilot, so that's what I'm using here. And if you need to install that also in your system, I'll help you out on that. Okay. Robert Scalar of DF3. Okay, it's awesome. It is also taking CF. I didn't mention, right? This also should have been DF1. So as it is became from DF1, DF2, next it is itself taking as DF3. Actually, this is an AI-based extension coming from OpenAI, a company of Elon Musk. Okay, so see here, this is robust scalar. Okay, so these are all like different things which is available and most commonly used. Gaussian transformations are not commonly used. Let me first do a QQ plot. Def QQ plot reports scipy.stats. Okay, plot dot show. We need QQ plot of df4. Okay, what is it here? Okay, sorry, my mistake. df4 of, okay, just a minute. I think I'm making a mistake here. try to pass it as like this df4 of, I don't know, let me check it once, okay? I think error will persist, but yeah, it didn't persist. Awesome. Uh, so GitHub Copilot, right? Sure. Yeah, yeah, we'll do. We'll make a video, sure. Uh, so here, if you see, like this is the line. This is the best line actually, the data distribution line. But it is like this. Okay. So it's not like specifically we can say we should do this only at this time. We should just experiment it. Okay. So we can make a plot on all the features in DF. Okay. So I'll just make a different plot. Okay. Instead of just altering the function, I'm just renaming the features. Okay. I need to alter the function for using feature actually there. We are having five columns. For five columns, we are having five transformations. Okay. So yeah, according to me, this one looks fine. Kind of a sigmoid curve, kind of a thing. This also is almost like that. So yeah, this one looks good. Wind speed 3 p.m. looks good. Aren't DF2, DF3, etc. are data frames? They are showing as array here. Yes, it will be shown as array because scalar returns that kind of an output. Okay, so yeah, now let's do transformation. Okay, hashtag logarithmic transformation. Okay, def log transformation, df. So you can also do like this. But if you don't want to, like make a, like what can I say, like explicit import, you can also do it manually by yourself. So how is it that I'll also show you that. Okay, so you can just import numpy as np, it is already done. Df of, okay, I'll just have it as, I'm going to have it as df comma feature only this time. Okay, feature, feature. I thought it would auto complete for me. Yeah, now it is doing. Do plus one here. Okay, so after that, just do, um, that's all. I think maybe a QQ plot of that should be fine. We'll make a QQ plot there. Okay, after that, so that you'll know what is the difference going on here. Df of feature. Okay, looks good. Log transformation. df4 wind gust speed. Here, how good guys? Just see here. How good is it? Could you explain about that n plus one again? See, it is not just like that. Like we are not. Actually, I think log one is zero and log zero is infinity. Actually, let me check it once. I just forgot it. Log zero value undefined. See here, yeah. Okay, so log 0 is infinity. Okay, so to avoid that infinity condition, what we will be doing is we'll be just adding plus 1. So you can ask, like, we are changing the value. No, I'm not changing the value because I'm adding 1 throughout the column. So it will nullify that plus 1, but it will also remove that 0 there. Okay, that 0 is removed, but see the transformation here. How it is, like, just this much is there in the line. But now see here how it is. Awesome, right? So as I said, like transformations are always good. So you can also print that. Okay. So here itself, I will do that print of df of feature. See here, it has become like this. Okay. It is also kind of a transformation. Awesome. Yes, it is awesome. I love Gaussian transformations a lot compared to feature scaling. Actually, like the scalars which we get in scalar, I don't like it. So next we can do exponential transformation. Okay. Exponential transformation. Exponential transformation. Okay. Yeah, you can also do like this actually. Okay, this is awesome. This is what we needed. But yeah, let's see how it goes. EXP transformation of DF4 wind gust speed won't work now. We'll see about wind direction 9A. Okay. Um. Yeah. How was it before? Okay. Doesn't seem like it has changed anything. Okay, so seems like it doesn't have any value change going on here. Okay, so which means you can maybe do some different transformations, for example like this. Okay, now it has been stored, I guess. Then exp just a minute. Plot show df of feature. Okay, so this is a weird column then, but yeah, worth a try. So next we are having, let me check if it is suggesting me anything. See, okay, it is not getting my. How it's getting. This is really awesome, guys. Whatever I'm expecting, it is just doing it actually. Okay. So reciprocal transformation of DF4 render 3 PM. So see here, it has become some like kind of an exponential graph actually. So yeah, see here, infinity. So it will happen. So like that's why we don't prefer it. So that time we can also do a plus one here safety. Okay, because why? Can you guess anything? Yeah, the data is weird. Very true. Couldn't transform it. And guys, just a question. I think Dhanlakshmi is only here. Dhanlakshmi, a quick question for you. Can you guess why previously reciprocal gave me a error, kind of a infinity graph, and once I added one, it is not giving me it. Did it? Can you get Can you guess why it is like that? Come on, it's very simple. Think logically. Come on, give me an answer. Okay, then I think you are not going to give an answer, I guess. Outliers caused it. Exponential increase in data. Outliers caused it. Yeah, I'm asking you, right? Why it transformed the data from a different distribution into that kind of a exponential distribution? Why it caused it? What caused it? Not outliers. See, what is the logical thinking you can think of here? Because I've just given a clue also. I've added one here, and after that one, reciprocal transformation gave me a better graph actually. So why is it like that? Any reason you can think of? Zero values? Yes, correct. That's the reason. 1 by 0 is infinity, so that is the thing which caused a problem. Okay, so be sure you don't make that problem. Okay, so yeah, that's cool. You correctly said how far square. See, yeah, sigmoid is coming. Okay, square root transformation we can do. Square and square root, whatever you want, you can do. Okay, that's square root transformation. NP dot square root of feature. That's all. Simple. The template is going to remain same. The way of transformation, this single line will change. Okay. Now do SQRT transformation of DF of not wind speed 9 a.m. What is it? What is the fourth one? Wind speed 9 a.m. only. Huh? Okay, fine. Then I think it again got what I needed. Here, awesome, right? See previously how it was. Wind speed 9 a.m. See here, it was having this much outside, right? Now lot of these fall inside. See here, except those, all of these are inside. So that's why Gaussian transformation is always good. Okay, that's why Gaussian transformation is always good, and I am a fan of Gaussian transformation actually. Okay, so I don't know if Ritesh here is a fan of Gaussian transformation, but you can see why I'm a fan of Gaussian transformation, right? QQ plot is there. You can just see how much it is fitting, very good. How much we want, how much it is fitting good, right? So yeah, finally we are having one of the most commonly used transformation, which is box Cox transformation, and there is one negative, guys. I'm just clearly saying now in box Cox transformation there is one negative, which is we can't have negative values in data. It will give you an error. Box Cox transformation of speed 3 p.m. So here it's not going to be a negative value, so it will work. See, guys, literally everything is now inside. How is it 3 p.m.? How is it previously? See here, it was the 3 p.m. before. How much outside, right? But see how it is now. Where it is now. Box Cox. That is box score. I'm becoming a fan of it now. Great reasoning for each transformation. Yes, that's the truth. Like I'm a fan of Gaussian transformation. I am not a fan of scale and scalars. I don't like it. But yeah, no reason we need to do that, right? But yeah, you can do Gaussian transformation also at times whenever you need. Okay. So that's about Gaussian transformation. What is the formula to do box Cox transformation? Just a minute, I'm showing it. Okay. This is the formula: y minus exponential of lambda minus 1 by lambda. Lambda is taken by itself. You can't do anything there. Okay. It will take by itself. But yeah, y minus exponential of lambda minus 1 plus lambda. Okay. So yeah, that would be one thing about transformations. So hope you loved about transformations. I hope it was helpful. Okay. Now let's see for train test split. It will be very short compared to that. Okay. Train test split, I'm not going to show you the hands-on now because train test split should be done after feature selection. Okay. So train test split, it is just to split the data into train and test. Okay. In real world, how we learn, like consider this is person. Okay, let me consider this as Ritesh. Okay, here there is a book on ML. So here, if you see, he'll learn all of this. Okay, so but how will he test him? How to test him? So he need to test him by data, or else like questions. Actually, in this case, it is questions related to the concept, but not seen. Okay, by that he'll try to correlate his memory, correlate his learning, specifically to say learning to the question. Okay, so yeah, in case of Ritesh, yeah, it's going to be 100% for sure. Nothing to talk on that. So it is going to be 100%. But yeah, so that's how, like in real world also, that's how it works. And in machine learning also, it is how, like it will learn from the data, the relations it will try to learn, and based on the relations we can test it. Okay, so that's about train test split. Train test split is not a huge topic to learn about. There are some parameters like stratify equal to y. At times we use it. Okay, other than that, there is not a lot to say. And if Ritesh is willing, he can talk about cross validation. Ritesh, can you speak a few words about cross validation here? Are you there, Ritesh?
Yes, yes, yeah. So see, in cross validation, what we do? Let's say we are having a
Hey, turn on your
1,000
turn on your video.
samples.
Video is not turned on.
Okay, okay. Wait a second. Wait a second.
Yeah.
Yeah. Let me zoom it little bit. Wait a second. Okay. Let me share my screen. Wait a minute.
Yeah. So actually, train test split is not just by sklearn or train test split. We can also do it by using cross validation. Both
I
the
hope
ways will
my
be
screen
there.
is visible to everyone. Okay. Yeah, cool.
Yeah.
So if you search for like for a just a diagram, uh, cross validation. Let me search. Okay. So in the Kaggle competitions, we what generally we'll do, we will create K folds, K fold cross validation we are having. So if you see here, like this is your training data, this is your training data, and this is your test data. If we sum up these, so we will getting a training data plus test data. Okay. So after getting a training data plus test data, this is our whole data, or you can say all data. Then what we are going to do, we are going to split this whole data into folds. Let's say you have mentioned in cross validation, or you can say in cross validation, when you are applying cross validation from sklearn, you will get the option of k, how many folds you want. So what we're going to do, let's say we have specified 5 folds. So what it will do, it will split your data into the small chunks. Let's say this is split one, and inside the split one there are 5 folds. In a similar way, we are having 5 splits, and then we are having fold inside that. So every time when your model is training, one fold, you can say one fold, or you can say in one fold is stopped for test training and another is for testing. Here you can see, if you see this diagram, let me show you a zoom one. Okay, I hope this is visible for you all. Let's see this only. So okay, so here we are having fold one. So this fold one is blocked for, you can say, training, and other are blocked for validation. Validation means there are two terms like training and validation. So whenever we are training our model, at the same point of a time we are also getting a validation score, checking the performance of our model continuously. So in the fold one, we are taking this as a training part, or you can say you can take this 2, 3, 4, 5 folds as a training, and this one as a testing or a validation. In a sim in a sim in the same way, we can have these all splits. And what is the benefit of having these all splits is like our model is seeing the whole data, not a particular split. If you do train test split, there we are having, you have divided your data. Let's say you have divided your data 20 80 20, 80% of training and 20% of testing. Now your model has trained onto the 80% data, but here it has not seen that 20% of data. To prevent that these all kind of a conditions, we are having k-fold cross validation. Inside that we are creating k-folds, and we are having n splits, k splits. And in every split we are going to assign a particular segment for training, particular segment for validation, so that our model can see all the possibilities which are present in our data set. So there are a lot of good visuals which are present here. So if you see this, we are having k folds. These all are the folds. This is the training fold, this is the validation fold, and these all are the splits. We have done 5 splits. Inside that we have done 5 folds. This is meant for validation, this is meant for training. In a simpler way, in a same way, if we go to the second split, in the another iteration, then we are blocking this for validation, another for training. This way our model has seen all the possibilities, you can say. So this is known as a k-fold cross validation. It is very common. Like there are different kind of folds, cross validation technique, like stratified k-fold. We are also having stratified k-fold. We are also having k-fold cross validation. Different kind of a techniques. You can even write your own custom function. Like you can put true and false, create a one column, put true and false, and do some kind of a random shuffling. Like at the time of a training, sometime pick the true, sometime pick the false columns. These are just a label so that we can have a mix. You can say our model is trained up on the whole data set. And that's why we have come up with this solution. Like in train test split, we don't have this kind of a feature. Like if you are having a 20% of a data blocked for testing, then you only test your model onto that 20%. That 20% is not included on the training data set. But in that, you can say in the training, in k-fold, we are having all the possibility. Every sector of a data has been visualized by our model. So this is known as a k-fold cross validation. I guess this is all about. You can see here like 80% of this, then 80% of a mid one, 80% of another sector of a data. You can say 20% we are taking for, let's say 20% we are taking for test. Then let's say first time our model has seen worked on this 20% of this whole data. Then another time a random block, or you can say a random sector from our data set, we are having 20% here. In a such way, we are scanning whole the data set for training also, for testing also. Model is training on whole data set. For testing, when we are doing testing, we are getting a good results by using this. You can see here, like use k-1 of the part for training and 1 for testing. K-1, if you are having a k data set, then k-1 for training and 1 for testing. So in a this is known as a k-fold. It is very easy to apply using sklearn. I hope it is clear. Any query? You can say, yeah, no, no, no. For the k-fold cross validation, we don't have such a big query. So same data won't be, yes, yes, same data won't be repeated in the next fold. You can say we are seeing all the possibility of the data, each and every possibility of the data. Do we need to take the average of all the performance? No. See, when you are having folds, it is similar to train test split, but the difference is we in train test split we are blocking a part of a data set. We are blocking a part of data set, but in this we are not blocking that. We are taking whole data set after one folds. So we need to average all the performance. No, you don't need to average all the performance, but this is done by the model. You can say these all are done by the model, if there is drawback. No, see, I have not seen any kind of a drawback, but sometime it overfit. Like sometime it kind of a overfitting for your model. It depends. Like, but it is the best way. I generally say like to use k-fold cross validation because trend test split is not a good way to split your data. I guess that's it, wasn't?
Yeah, yeah. So that's why I just wanted you to talk about that. Like, we can do train test split. Even we will be doing train test split, but it's not a good practice to do train test split. Always we can do careful cross validation. Okay. So yeah, that's it for today's session. I hope you all like the session. I think only one is here. I think there is no word to say like all. So yeah, hope you like the session, and yeah. So next our plan is tomorrow I'll be wrapping up about feature selection, and also I'll say like how to do feature extraction. I'll talk about that, and if time permits, I'll say about model creation because there is not to do a lot on model creation. So what can I say? Like if possible, if I complete machine learning model tomorrow, in the day after tomorrow session, which is on Thursday, I'll complete the tuning and I'll discuss the whole project code, and I need not discuss anything. You will just know, okay, you're doing this, you're doing that, because all the steps I have done, I have detailedly explained here, more detailed, like all the parts actually. To say it took me a lot of days or lots of months to do, like to know this kind of a session. Like whatever I got in this session, it's kind of a, like end to end thing. It is not easy to like easily get a hold of these kind of things, like very soon. It took me a long time. I needed to research for resources. It took me a long time to get resources and then learn about it and then get to know the flow. But yeah, that's why I made this bootcamp. Hope everyone will be satisfied by that and then will be benefited by that. And yeah, so if it is done on Thursday, if the project discussion is done on Thursday, Friday our buddy Ritesh will be talking about deployment and ML ops. Ritesh, right? Ritesh?
Yeah, yeah, I will be.
Yeah, and what is Ritesh? There is whatever we have discussed here, it will take a long time to learn if we are learning by ourselves, right? Without any courses.
Yeah, definitely. Like, yeah, definitely. If you go to any YouTube video, I'm suggesting you to go to any YouTube video, and they are you can't go through. You need to go through some kind of a 4 to 5 minutes tutorial every time. Like, what generally I've seen, like when I'm studying the machine learning. So if you go any YouTube channel, so there you need to go through the like 7 minute video. Again, you are not able to find the another topic what I need to learn. Like no one can tell you like if like the way like we are having this component ML life cycle, this component in ML life cycle, and start with this way. They just say you see this playlist. In this playlist, all things are present, and that in playlist all things are not present. Trust me, all things you can't get, like what is robust scalar, how to fix the missing values. You can't get all the particular solutions in that 7 to 8 minute video. But here, like at the end, you will realize like it is also like not that machine learning part, but also the deployment part. We will see like how to like all the operation part, like ML operations, like the best video on the ML operation. Like I will tell you all these latest tools which are present onto the market, so that you can get about it, and after that you can explore it by yourself. Just a little bit push I will give you, like. how you can work with it. Yeah. So you can't find like
And
such a like bootcamp where we are having such a long see, we are daily going to create videos, and then we are going to work on like 1 hour we are going to dedicate it. Then at the end you are also getting a deployment part. It is very tough. Like if someone is going to create, it will generally take 6 to 7 months to these all boot camps. Like you can set to these all 1 hour video. You will get their whole sort of long playlist for that. Yeah. So yeah, it's if the session like if there are no person, then it is good. Like no person, people are coming, not coming. It's depend on them. Like, but we are also going to have like NLP and computer vision sessions. So don't miss that in
yeah,
the upcoming
as I
future.
said, guys, like I am into just giving everything to the community. That's all. Like if I wanted to earn something, I would have surely gone for a like special boot camp. Like either go to a Google Meet or a Zoom and then invite you all, get some money from you, 500, 600,000, whatever it is. Like even this content you won't get it for like 1,000 in boot camps specifically. Yeah, there are courses. For example, even I neuron course contains like huge lot of content. Yeah, that is all like very huge. But what I've done in this boot camp till now is I've made you know about the each and every life cycle. Like in pre-processing, whatever you need to know, you now know it. Like if you have followed the bootcamp correctly, you are now ready to pre-process the data set. I'm very sure on that. Yeah, you need some practice that I accept it, but like the knowledge, base knowledge, this is more than enough. More than enough, I'll say, because that's how I Ritesh, like we both are sustaining in this industry knowing just this much. I don't even know more than this. Okay, I'm frankly speaking, I don't use any other pre-processing techniques. I just know this much only. So yeah, as I said, like if I say N2ML bootcamp, it is truly end-to-end bootcamp. Okay, so that's why even I added deployment. Okay, so yeah, I don't know if you are not attending live. It's upon your wish, guys. Like whoever is watching this recording and not attending live, yeah, not a problem for me. Okay, so if you are joining, yeah, like you'll get an opportunity to ask doubts to us, and then we'll be able to clear it. Okay, so yeah, it's upon you to watch it as recording or live. But one thing I can assure you is once you complete this bootcamp, you'll find yourself as a better person in machine learning. I'm very sure on that. Okay, Kaggle problem statements will be very simple for you after that. Like you'll be easily able to approach a Kaggle problem statement. And yeah, there are a lot of videos in pipeline for me. So at times, yeah, Ritesh is here. I'll invite him. And guys, if you have not subscribed the channel of Ritesh, subscribe to his channel also, so that like he'll make a live and all soon live videos. So when he's making, just you can watch there. Okay. So yeah, appreciate your initiatives. Keep supporting like this. Will do. Yeah, I'm just expecting the same thing from you. That's all. Like just support us. Your support, obviously, like just subscribe, like the channel, like the videos, comment your opinions on the channel. Okay, and then like share it, max, please. Like I'm just making as a request, and help me reach 500 subscribers. Okay, just 500. I'm not straight away going for 1,000 and all, because 500 means a lot to me because I'm a beginner YouTuber. But usually if you see beginner YouTubers doesn't go live, they don't prefer live actually for this reason. No one usually joins their live. That's the only main reason. And then another reason is they possibly might not have the confidence to speak in live. Possibly, I don't know. Nothing to comment on the YouTubers here. Okay, I respect the job, knowing the pain of a YouTuber. Okay, but yeah, I'm doing it live because I could have done this as a recording, but what will happen is whatever Ritesh said, that will happen now. Like I'll make a playlist and you will be not able to follow it. Okay, so that's why I'm making it as live, so that if you watch one video, you should be able to know one concept. For example, if you watch missing values handling, okay, man, now I'm ready to handle missing values. That's all. Okay, so yeah, that's it for today's session, guys. Like okay, so if you have not liked this, like the videos, please like the video. Okay, if you have not like shared your friends, just share it with your friends, whoever it is. Like whoever just starts with data science, just send them this boot camp. I'm assuring you, like, this is, uh, even if you paid for this, you would have been happy, but I'm just giving it for unpaid. Okay, so just share it with your community and a lot of people. Okay, and then if you are not subscribed to the channel, just hit the subscribe button and hit the bell notification. And yeah, let's see in the tomorrow session. So Ritesh, do you want to anything, like, no, do you want to add up anything on the bootcamp, or else any other things you want to talk about?
No, no, yeah. I will talk about one turning scheme. Like, for today, it is awesome. Like,
Yeah,
everything, like,
great.
great.
So yeah, thank you guys. I'll see you all in the tomorrow session. Okay, bye.